All right. Good afternoon, good morning, everyone. I think we're going to get started. Um, my name's Thomas Leonard. I'm the product marketing manager for Socomec in North America for our power switching and power monitoring division. So today we're going to talk about energy codes, IECC and ASHRAE 90.1, and more specifically, we're going to talk about the submetering requirements that are involved with the compliance of these energy codes. So the agenda for today's webinar, I'll give a quick introduction and give some background on the energy codes. Then we'll look at what the submetering requirements are. Um, we'll take a look at typical project examples and and then talk about considerations, what to look for in a power meter when um, to best comply with the energy code. And then we'll finish with taking a look at some of the Socomec solutions that can help meet the energy code requirements. Okay. You should have a Q&A section at the bottom, so I'll pull that up at the end of the webinar and answer as many questions as possible. So if you have any questions, please use the Q&A section. All right, let's start with the introduction about the energy code. So, um, you know, energy efficiency standards, energy codes, they're really a critical role in reducing the energy consumption in buildings. So, the U.S. building codes are designed to they set guidelines and minimum efficiency requirements for new buildings. The main goal of energy codes is to reduce energy consumption, to reduce greenhouse gas emissions, and overall to improve the building performance. There's multiple sections in the energy code. The energy codes talk about building envelope with categories such as insulation, air leakage. There's categories on mechanical systems, so HVAC. There's sections on service water heating, lighting systems, and electrical power. The metering parts are specifically in the electrical power section, so that's what we're going to look at more in details today. The IECC and the ASHRAE 90.1, they're the two most widely adopted energy codes for commercial buildings. IECC is actually both for residential and commercial buildings, but ASHRAE is specifically commercial buildings. Both are recognized by the Department of Energy as as a reference for energy codes and for compliance. The most most of the states are based on the IECC, but like I said, both codes are recognized by the Department of Energy. There's of course a relationship between IECC and ASHRAE. So when if you're compliant with ASHRAE, it's generally accepted that you will be compliant with IECC. So there's a close relationship. Both codes are updated every 3 years, so it's a 3-year cycle, and each state can choose to, when there's a new version that gets released, the state can choose to opt for the latest energy code revision, or they can choose to amend it or to remain on the previous version of the code. So, and here we're showing a map of the US with the energy code revision, which is directly from energycodes.gov. So you can consult it real time. They update it, multiple times a year. So you can see what the map looks like. It's kind of a patchwork of code adoptions. So it's something provided by the Department of Energy. So you see the blue colors are, the more recent energy code versions, and the yellow, the orange, or the red are the older energy code revisions. Once a code is adopted at the state level, then it's up to the local jurisdictions to enforce it and to adopt that version of the code. A few more info on the energy code. So, the state level code sets the minimum requirements, but, like I said, it's up to the local jurisdictions to enforce it. And, certain cities or counties can voluntarily go beyond the minimum or the base code. So they can implement an enhanced or they also call it a stretch code, which is a more aggressive or a more recently updated standard that is designed to achieve greater energy savings. So there's a few examples. Austin, for example, they implemented the 2024 IECC revision, which is the latest version. Based on the 3-year cycle, there should be one in 2027, but the latest one is 2024. So they adopted it in July 2025, but the state of Texas as a whole, it is still in the 2015 IECC or 2013 ASHRAE. So that's one example. The second one is Denver, Colorado, which adopted the Denver Green Code in 2022, which is closely aligned with the latest IECC, so IECC 2021. But Colorado actually is not enforcing a statewide energy code. So there's a few examples where cities are adopting more stringent energy code revisions. So let's look at the submetering requirements in the energy codes. There's specific requirements. One of them is to monitor energy use across multiple load categories. So we'll see that in the next few slides. There's a few differences in the codes, but at the end of the day, they share similar objectives. The goal is to really track energy consumption to be able to make informed decisions. But there's, because the states adopt the codes with amendments and because they adopt codes at different times, you can see that not every state is concerned by the submetering requirements. So it's really we try to provide a list per state, and every year this list is getting updated as new states are adopting the latest energy code. So it's almost an annual process of checking if a state is concerned by the energy by the submetering requirements, because they might enforce the latest energy code version, but even if they do, they might have amendments where they want to exclude the submetering requirements. There's been submetering requirements for a few years now, for a few, even in the former code revisions. And each new code revision keeps, it gets stricter and stricter in terms of submetering. So we'll talk a little bit about that. But why is the energy code asking to implement submetering? What's the reasoning behind it? Well, it's, the U.S. Department of Energy's point of view is pretty simple. They estimate that there's a 5 to 15% saving associated with implementing energy metering, just from the building owner, the energy manager becoming conscious about their energy usage, and because of the data collected by submetering, so just highlighting how the energy is being used, they estimate that this is providing a 5 to 15% saving on the energy consumption of the building. So the goal of having submetering within a facility, within a site, is of course to identify areas of inefficient energy usage. Having submetering allows to allocate energy usage to different buildings, load types, usages, different tenants. So just highlighting some energy that is not being allocated correctly. Having submetering allows to make sure the um, demand profile is adapted to the utility contract and vice versa. So avoiding penalties due to that can be due to demand spikes. And having submetering, you're complying with energy regulations, which might be um, nationwide, it can be citywide. It really depends, but complying with the local energy regulations, monitoring improvements, which is essentially what the code is asking for, is monitoring continuously and making sure that they can set realistic targets for the next few years. So that's some of the goals for implementing submetering, and there's more. At the end of the day, having submetering and being able to identify wasted energy is to save on utility costs as well, to make sure that there's an improvement in the um, utility cost at the end of the month. So let's look at the submetering requirements in IECC and ASHRAE 90.1. So very, very similar. They're very, like I said, they're kind of tied together. There's nuance differences, but the requirements are closely aligned. Um, the, the big requirement is that both ASHRAE and IECC require the use of meters to collect energy use for each of the following end use category. So a separate meter for each of the different load categories. And the load categories are shown on this table. So there's a few. There's total system, there's HVAC, there's interior lighting, exterior lighting, plug loads, process loads, renewable energies, water heating systems, and refrigeration systems. So depending on the energy code, they're not always the same categories. HVAC, lighting, plug loads, those are common between IECC and ASHRAE. As for the other ones, there's a few minor differences. For example, ASHRAE is not requiring to monitor process loads. Um, Same thing with renewable energy systems and water heating systems, but um, they do require refrigeration systems where IECC is not requiring that. So those are the different load categories that the standards are asking to monitor individually. They also require individual tenant spaces to be submetered if they exceed 10,000 square feet. So, if you have an office building with tenants that have more than 10,000 square feet of space, those tenants are supposed to be submetered individually. Now, regarding the building size, so ASHRAE is only for buildings that are over 25,000 square feet. And ICC was the same threshold, but it was actually reduced to 10,000 square feet. So it makes it more stringent and includes more buildings now. So any new building that is over 25,000 square feet or 10,000 square feet, depending on what code is adopted by the state, has to comply and has to include individual submetering for these load categories. Um, we're only talking about um, new buildings and building additions or, you know, uh, undergoing significant alterations, renovations, but it's mainly for new buildings. Of course, if there's a building addition that exceeds the building size, the requirement, so the 25 or the 10,000 square feet, then that new extension, that new addition has to follow the energy code requirements. Um, the application, so it's only commercial buildings, so it doesn't include residential. So it's only office buildings. I mean, those are a few examples, but office buildings, retail, warehouses, and industrial facilities as well for the commercial building part. So those are the submetering requirements. There are some requirements about the data acquisition systems. They say the standard says that the building must include a data acquisition system that's capable of collecting, storing, reporting data from the required meters. Um, the system has to provide hourly, daily, monthly, yearly data, and the system has to be capable of logging data for a minimum of 36 months. Now, this is a separate part in the energy codes. It's under data acquisition system. So it doesn't have to be part of the metering system. It's usually a separate system that's you know capable of reading the data from the meters and storing and providing dashboards. So put a few examples on this slide of companies that are providing these types of services and that are capable of reading data from meters and providing dashboards and that are storing the data for the required period. So those are just examples. We're going to look at some typical examples of how submetering can be implemented on projects. But first, there's going to be a quick question that Rachel is going to initiate. So if you everybody should see this quiz. So the question is, how can you know if an electrical takeoff, if a project includes submetering, how can you identify that? So there's a few options that you can choose from. Okay, I think we're good. We can close the question. See if so. What was the right answer? Well, the right answer was all of them, all of the above. Um, a lot of the electrical takeoff projects do include submetering. It's more, it's a matter of being able to locate where and to understand what solution is required. But there's different ways. That's something we all use is you can use Control F in a PDF document and look up the word meter. You can you can take a look at the sheet notes specifically in the electrical section um, to locate any submetering requirement, which is usually where the IECC or the ASHRAE will be mentioned. So take a look at the sheet notes. Um, and something that's a little bit easier is to check on the one line if there's a circled M or a CT symbol. Sometimes it's just going to be a little note that refers to the sheet note. But those are just examples on, how to know if that project is asking for submetering. So it was, yeah, all of the answers were correct. Take a look at a few examples, that to illustrate what I just said. So different one-line diagrams showing circled M's or little CT symbols. This is how you would recognize on an electrical one-line diagram that there are meters that are required and that the engineer was putting in the design. So you see the M, the CT symbol. Sometimes it can be a PMM, or sometimes it can even be a numbered note, and then you have to refer to the sheet notes to understand if what the engineer was asking for. And this is the type of sheet note that you might run into. So this one's pretty typical. Submetering of the variable load types is required in accordance with ASHRAE 90.1, and then they just list the different load categories. So what we'll see a lot is this note, then the one-line diagram with the meters, and then there'll be panel schedules, circuit schedules that really provide the details of which circuit needs to be monitored. And if the engineer is doing things right and is making it simple for us who are supposed to provide the right metering solution, they will say which circuit needs to be associated in terms of load category. So when they'll provide a panel schedule, they'll say, well, these three breakers, this is for HVAC, these three other breakers, this is for plug loads, these three breakers, it's lighting, so that whoever's doing the metering design and the product selection can identify or can best choose the right solution. A few examples. So let's, consider this one line diagram. So a main switchboard with a few subfeeds that are feeding several panel boards. And in this example, we're assuming that each subfeed, is feeding a single load category. So each panel board is actually, includes circuits of just one category. So panel board one is only indoor lighting, panel board two is outdoor lighting, then HVAC, process loads. So here, if you want to account for all the load categories, it's pretty simple, right? All you need to do is to monitor each individual panel, and you'll know that the panel accounts for the entire load category. So there's two options in this case. You can use a multi-circuit meter at the switchboard level, right? So you go, in the electrical room, which will have the switchboard, you have one multi-circuit meter and different sets of CTs that are going to monitor each subfeed breaker. So that's one option, and that concentrates everything into one device. So it's one Ethernet connection to connect it to the building management system. It's one installation, which means one voltage reference. It's more compact. It's less time installing. That's one way. That's one efficient way to do it in this case. Another option is to, of course, install individual power meters at every panel board to capture the main feed of each panel board, and that's also a possible solution. And sometimes that's what the customer or the engineer is asking for, is to have independent individual meters. And sometimes those panel boards are going to be in different parts of the building, right? They're going to be in different rooms. So there's that's also a possible option. But this is an example where, it's not the most realistic example, because this is where load categories would be split upstream and each subfeed is feeding one load category. The reality is more example number two, where the loads are not separated upstream, and one subfeed within the switchboard is going to be feeding panels which are going to have different load categories. So one panel like PP2, for example, is going to have a mix of lighting circuits, HVAC circuits, process loads, and lighting and indoor lighting, right? So same thing for the other panel. They're going to have a mix of different load categories. So in this case, you are going to need individual power meters, and they're going to have to be multi-circuit power meters at each panel. And this is very common. This is what we see the most, is when you look at the panel schedule, the engineer will circle the different circuits, and they'll have notes at the bottom, footnotes at the bottom of each panel that say, okay, this breaker is HVAC, this breaker is lighting, this breaker is plug loads. That way it helps us define the right metering solution, how many CTs need to be used, what amperage for each CT. So that's something we really need from the engineers, so that we don't make assumptions. Otherwise, you either monitor the main feed or you monitor everything, but you're going to provide not enough, or you're going to provide too much, and the cost is not going to be what the customer's expecting, and it's not going to be what the code is asking for. So now we're going to look at the submetering solutions. And first, there's a few important considerations to help best select the submetering solution. So the first one is space constraints, especially when there's multiple circuits that need to be monitored within a panel. Sometimes it may be challenging. The internal space within the panel might be challenging. So in this case, it's a lot of times it's easier to provide enclosed metering solutions that can be wall mounted near the panel or even installed in a separate room, um, which provides a more practical alternative than having meters internally mounted to a panel. A lot of times it's not possible to have meters built into the panel when the panel is already installed at the site. So having solutions like multi-circuit meters that are housed in a single enclosure can help save space and simplify installation compared to deploying multiple single point meters. Um, the second one is granularity. So, you know, providing granular power monitoring solutions, monitoring individual circuits at the panel board level, at the power panel level, allows to collect individual kilowatt hour for each load category. Uh, like I said, each load category is not always grouped together at the switchboard level or even at the power panel level. So sometimes you really have to go to the panel board level and to provide individual circuit metering. So you have to find solutions that do provide that level of resolution of and granularity. Installation. So of course, selecting submeters that are easy, quick for electrical contractors to install. Um, Working with metering vendors that are offering startup services to make sure that the power meters are correctly uh, programmed so that we can verify that the meter is also wired correctly. If there's a wiring error, we can fix them in the software. So just making sure that um, the data, the measurements that are being communicated to the BMS are reliable and correct. And the last one is the BMS, BAS integration. So selecting submeters that integrate seamlessly within building management systems. So making sure the power meters that are selected are universal in terms of communication protocols. They work with open Modbus protocol or BACnet, which is pretty common in the industry. So yeah, selecting power meters that are open and that can work seamlessly with different BMS, BAS systems. So those are some of the considerations to take into account. Now we're going to take a look at the Socomac solutions. So we have a full range of enclosed solutions that can be mounted on a wall by an electrical contractor. So that saves a lot of time because they don't have to take the meter, source an enclosure, and do the installation and the wiring. We provide factory pre-wired uh, enclosures that we make ourselves in our Colorado facility. So we have the Digibox A, which is for, we call it a single circuit enclosed meter. So you're monitoring one load. So if we take example number one, where we really all we needed was to monitor the main feed to capture all that category. Well, in that case, that's enough. So the Digibox A and then the Dyrus MCM, which is really great for high density metering when you have panels with multiple circuits, whether it's a switchboard or a panel board, all that matters is the CT the current sensor that you select to interface with the meter. But the Dyrus MCM, that's very cost effective for monitoring multiple circuits. So the example number two, when you have multiple loads within the same panel, that's really a great and cost effective solution. So this is the Digibox A, and we have the Digibox A40 or the Digibox A200. The difference is in the measurement capabilities. The Digibox A200 provides a little bit more with power quality, with waveform capture. So installing it on a main feed is valuable. There's added value for the customer if they want to check the incoming power quality. It's the exact same box. It's just the meter technology that's inside. We can have the Dyrus A40 or the Dyrus A200, depending on the one that you choose. But they're ideal for electrical contractors. Like I said, they're enclosed, they're factory pre-wired to UL 508A panel shop. So you're getting a certified solution, safe solution. It includes the fuse protection inside. It's the Socomac technology, so it's got a class 0.5 system accuracy, including RCTs. So it's not just meter accuracy, it's meter plus CT accuracy. It exceeds revenue grade standards. So that's the Digibox A for single point metering. Has built-in communication, of course, so Modbus, BACnet built in. And then the second solution is Dyrus MCM, which is, like I said, the high density multi-circuit power meter. It's available as a 16 CT, which is our Dyrus MCM 16, or a 48 CT input, which is the Dyrus MCM 48. So with the Dyrus MCM 48, for example, you have, you can monitor up to 16 three-phase loads, 16 three-phase breakers in a single enclosure. So you're really saving a lot of time on the installation cost, on the installation time, because you have a single voltage reference and you actually have two separate voltage inputs. So you can even monitor circuits from different voltage sources. So if you have a transformer, 277 to 120 volt transformer, you can monitor loads on both sides and make the right correlation. But it's really a cost-effective solution to monitor multiple circuits. So MCM 48 up to 16 three-phase loads or 24 split phase. We're starting to see some traction with tenant billing applications, which are split phase loads where you need two CTs, while one enclosure, one MCM 48 can be used to monitor up to 24 tenants. The MCM is compatible with all service types up to 600 volts. So whatever the service type, whether it's 120 volt, 277, 347 volts in Canada, I mean, it's compatible with all service types. Same thing with the Digibox A200, by the way. It's compatible with our millivolt CTs. That's a big benefit for contractors as well, as all of our CTs are millivolt based. So they don't need any shorting blocks. They're split core. They can be easily wrapped around conductors and or bus bars. So for existing panels that are already on site, it's a huge help and a lot of time savings for the contractor. For the MCM, it also has built-in RS-45 Modbus and Ethernet Modbus or BACnet communication. So it's it reports data to any third-party BMS software. So that's really a great solution that was specifically designed for electrical contractors that want to deploy, submetering easily and in a fast way. It's packed with features that are making the installation easy and safe. So there's built-in conduit holes. There's a safe voltage cover. There's color-coded terminals. It's really a unique solution that's going to help electrical contractors implement those types of submetering projects. And if we look at a typical example, so if we go back and at example number 2, this would be a typical example to meet energy code compliance. So you have multiple panels. You have one panel here that only includes one load category, and then you have different panels with multiple load categories. This would be a solution. You use a Digibox A and you're monitoring the main feed of that panel using, for example, Rogowski coil CTs. And then you use the Dyrus MCM multi-circuit enclosed meter with different sets of CTs to monitor each circuit that is relevant in the panel. All those meters are connected over the local network. So it's an Ethernet cable connected to the local network. And then it's a matter of the data acquisition system. So one of the companies that are mentioned that provide energy management software and that can read the measurements through Modbus or BACnet and integrate the measurements into their platform, into their dashboards. Or we also have a solution. We have a data logger that's really an entry level energy management or energy visualization software. So it basically reads Modbus data from the different meters. It stores the measurements in a 64 gigabyte memory card, and then there's a web page that provides basic web-based reporting to visualize consumption. So that's a typical example for a simple situation to provide compliance. That's great for electrical contractors. Like I said, all those meters are enclosed and ready to be installed in on a wall. We also have solutions that we're not going to talk about too much, but we also have the Dyrus DigiWare system, which is more built in for OEMs, for switchboard and panel board, lighting panel manufacturers, so that the system is integrated directly, built in directly into the panel. So when the switchboard manufacturer is selling the complete system, it's an energy code ready solution. So you have both, you have two approaches, whether the project is more contractor led or OEM panel builder led. Um, there's a full application note available on our website if you want to find out more about the energy code requirements and the compliance and find out more and have more examples. You can download that application note from that QR code directly, or if you go on our website, if you look up if you go to the solutions section at the top, and then you'll find the application note. So it's a PDF that y'all can download. That's all for me. If you have any questions, feel free to ask. Thanks for joining the webinar. I'll take a look at questions to see if there's any Q&As. There's a question about medium voltage. So do we have anything we can offer on medium voltage systems? Um, Technically, all of our power meters are compatible with medium voltage systems. They have to be used, they have to be connected through voltage transformers. So they're the direct connection, of course, up to the meter is up to 600 volts or 690 volts. So they have to be connected through potential transformers. And then the meters accept a ratio. So you can configure a primary and secondary ratio on the power meter to be able to monitor medium voltage. As far as the CTs, typically the Rogowskis will be used around insulated cables. So even if it's medium voltage, that's typically what is being done. Let's see. Do you do you do you address power quality issues or mitigations? So some of the power quality meters that Socomec offers do monitor power quality. We're able to set up some alarms and based on thresholds, and we can record like sags, swells, interruptions. Um, we're not an active device. We're monitoring and we're reporting those issues. So we'll have dashboards, we'll have waveform capture examples that are provided on the web-based software on WebView to show that there's been an issue, that there's been a sag, a swell. So we have a proof with the waveform, but it's we're not an active device, so it's more used for monitoring, and we're providing reports so that if there's been issues and if there's been consequences on the production on equipment, then the customer has proof that and it was recorded by a power quality meter. When looking at plans and specs, who would be some competitor names in submetering we should be looking for? I'm not going to disclose that in the webinar, but if you can shoot me an email and we can talk about that. No problem. Um, let's see. So space and multi-circuits in a panel are the only two requirements for submetering need. Um, it's not really the submetering requirements are to monitor the different load categories. So depending on the building design, it's up to the engineer to say, okay, these are the circuits that need to be monitored within a panel. It's up to the engineer to decide if monitoring the main feed of that panel is enough, or if multiple circuits within that panel is need to be monitored. So that's the requirements. So it can be a mix of different solutions, single point power meters and multi-circuit power meters. Can we get a copy of the slides? Yes. There will be actually the application note that I referenced to in the previous slide that you can download on the website is a more detailed version of those slides. Um, and the recording of this webinar will also be posted on the Socomec website. What is the value of data centers from metering other than power consumption? Um, so yeah, I mean, data center is also concerned by some of these requirements. The main reason data centers implement power monitoring, aside from being efficient and making sure that the building has a good PUE and making sure that the building's efficient and that they report energy use. I mean, the key reason they want to implement metering is is what they call capacity planning, capacity management. So they want to know what how loaded the breaker is, what the load level is, because they want to make sure that the breaker doesn't trip. So they want to make sure each breaker stays, below 40%, for example, so that they know they can't add more servers to the rack. So it's really a different application than what I presented today with the energy code compliance. All right, I don't see any more questions, so if you think of anything else later, feel free to shoot me an email. You have my email address, I believe, in some of the answers to the questions. And Rachel also put the link directly on the chat I see, so you should have everything. Thank you. Thank you, everyone. Have a nice afternoon.